So why do scientists care about knowing the number of particles like atoms or molecules if they usually measure substance by mass in the lab? Because knowing the number of particles help us to relate it to a measurable mass. So I know how many moles has reacted, so how many molecules or how many atoms has reacted, and what is the mass of that fraction. Now it's time to connect the mole to the gram, and that's exactly what molar mass does. Molar mass, it explains itself. Molar mass, the mass of one mole. Molar mass tells us how many grams one mole of substance weighs on our balance. It's written on the periodic table for every element. What is the unit for that? Grams per moles. Grams for every mole. So if you know the number of moles, you can find the mass easily. Mass is equal to moles by molar mass. But how did we get that? Understanding. What if I told you that I have 1 mole of iron atoms? 1 mole of Fe atoms. Let's see if you understand if this is too much or too small. What does this mean? It has what? You have 1 gram of Fe. Does this mean you have 1 gram of Fe? You have 26 atoms of Fe. You have 6.022 10 to the power of 23 atoms of Fe. You have 55.85 atoms of Fe. Let's take this carefully because this is our first example. You cannot say you have 1 gram of Fe because the mass of 1 mole I can get from the periodic table. I will look at the periodic table and see that Fe is written 55.85. So I'll just have to take this number and put it in grams. So I will say mass of 1 mole of iron atoms is 55.85 grams. So this is a correct answer. You cannot say 1 gram. It does not weigh 1 gram. The mole of iron does not weigh 1 gram. You cannot say 26 atoms. 26 is very small. You have 6.0. This is 1 mole, and mole is 6.022 times 10 to the power of 23 atoms of Fe. So these two are correct, and these two are wrong. Try this one. If you were asked, try this one. The periodic table says the magnesium atomic mass is 24.3. So you went to the magnesium and it's written magnesium and 24.3. What does this number mean? It means that 1 magnesium atom weighs 24.3? No, we said this is the number is the atomic mass or the molar mass. That's the mass of 1 mole. This is the mass, the number that you see in the periodic table is the mass in grams of 1 mole of the magnesium. So it's not 1 magnesium atom. It's much more than that. It's 1 mole of magnesium atom weighs 24.3. That's correct. There are 24.3 atoms in magnesium? No. Magnesium has 24 protons. That's no. So this is the correct answer, number B. The easiest way to understand that is to imagine we have two different balances. One is a small, tiny one. This is for the atoms that we cannot see. Here, if you compare the hydrogen and the iron atoms together, they are nothing. Can you see this by kilogram? 1.67 times 10 to the power of -27 for 1 atom of hydrogen, and 9.27 multiplied 10 to the power of -26 kilogram for 1 iron atom. This is nothing. However, you keep adding hydrogen atoms or iron atoms, it doesn't change anything in the scale. You cannot feel the difference. It's impossible to feel the difference between these two together, and that the microscopic balance cannot know the difference. But in the moon world, 1 mole of hydrogen will give you 1 gram, but 1 mole of iron is 56 grams. That's big difference. We can see the difference here. The balance the normal balance in our life can automatically know that this is bigger because this is 56 grams and 1 gram. But here there are too tiny to be measured by our miniature or tiny balance.